solution of exam 11. I repeat what I said in the previous exam. If you have not studied and if you have not tried to do the exam alone, it's a waste of resources to try to do this to watch this video. You should first study, then do the exam alone, restudy, do the exam alone, and then only finally watch this video. So I give for granted that you have already tried to do the exam alone at least twice. Okay, let's see. There is the access part, which is optional for people who do the homework, and the R part. Okay, for the access part this time I will not give you the schema before, well, because I hope that you know very well the schema here. Now let's start, however, getting the files from exam Coletti. So I open this PC, //ubz01fst. I have to type also this extra thing because I'm at home, as you can see from here, connected in VPN. Okay. Courses, not exams. If you go to Course Coletti, usually, sometimes I'm so kind to warn you, but other times I'm not. Exam Coletti, you will find a long list of people, locate yourself. Okay. And take everything and copy on your desktop. If your desktop is a mess, like mine, you should build a directory and copy inside that directory. Yes, copy, please. Okay, now I don't close this folder here. I simply iconize it, minimize it. I enter my directory. Okay. I don't click randomly. I read, open my Northwind 2003, because sometimes I give you a file, but it's not required by that exercise. Enable content. Okay, fine. Create query one, which displays suppliers company name, their products product name, and the category product category name, skipping discontinued products. So create query wizard. So suppliers company name, products product name, products category name, so from categories. Skipping discontinued products, so I need also field discontinued, which is in product. Discontinued. Next, give it a name, query 1. Giving the wrong name is the best way to lose 1 point. Home, view, discontinued, skipping discontinued, so discontinued no. Okay, I don't show. Do not display discontinued field. Let's see. Yes, save and close. Create query 2, which calculates for each customer and for each employee the number of orders handled by that employee for that customer. Pretty easy. Well, I will do it with query design. We are advanced users now. From table customers, I add a table employees, and I have to count the number of orders. So, okay. So for each customer, company name. For each employee, last name. I will count the ID. Count. Something else? No. So I save it as that. I am very tolerant concerning the capitalization, so you can type query2. Let's see, however, whether it gives some results. Yes. Okay. To table employees, add field retire date and insert an appropriate validation rule which checks that retire date be later than hire date. Retire date, it's a date. Validation rule. Oh, if you do something like this, it's wrong because you cannot put fields here. You have to save, create a table validation rule, retire date after hire date. Retire date must be after hire date. Okay, save. Yeah, it doesn't matter. Yes, yes. Uh, wait. Save. Okay. When Access asks, oops, I didn't read it. I didn't read it. When Access asks, answer that you do not want to test again. Oops. Okay, you can see you have to read at least the entire point completely. Create form 1 to modify insert employees, lock it to avoid employees deletions. Create form 1. Let's put form 1. Okay, locked, so I have to switch to design view, property sheet, data, to avoid deletions, so deletions. No. Save and close. Create a report 1 that displays employee by employee, shipper by shipper, the customers with which the employees had to do. So, okay, so we don't need any other query, so we can directly create a report. Where is the report wizard? So employee by employee, so employee last name, shipper's company name, customer company name, and order ID. Well, it's pretty easy. Done. So easy. I will have to group. So first of all, group by employee. Okay. Then group by shipper. And then group by customer. Ah no. Employee by employee, shipper by shipper. Okay, we don't have to group by anything else. Okay, no sorting. The name is report 1. Finish. Let's take a look at it. Employee, shipper, Okay. Close. Build query import restrictions, which deletes all the product coming from French suppliers. Do not run it. So create, well, let's do it in design. Suppliers, products, close. And from suppliers, I need only the count. I don't need anything else. Okay, criteria, France. Okay, let's convert it to a delete query. Pay attention what you're doing. Drag, for example, product ID here. No, I don't have to delete. Let me see. Okay, so if you must drag the asterisk. In this way, pay attention to delete where from. It means that you will delete things from here. So pay attention not to delete from suppliers. Okay, because the French supplier must remain. Only the product must be deleted. Okay, don't run, but I think that even if you run it, Access will stop you, because if you delete French products, some old orders will have problems. In any case, save it as import restrictions. Okay. Up. Done. I close. I have here my file. I now, just to be sure, to avoid forgetting at the end, I will copy it on the network directory. Okay. Question, pay attention, you're copying from desktop to my network directory and not vice versa, so replace. Okay, let's switch to R. So we have to use R, our commander, and data from dataset students, giving workspace students.rdata. In this case, I gave it to you. So first of all, let's launch. I have it here. Well, for you, it's better to have it on your desktop and not spend 3 hours searching for it. Our portable packages, load package, our commander. You change working directory. Up. Okay, fine. Have to load the workspace from here. Pay attention to your in the right place, exam students.rdata. And then tell it to our commander that you have loaded a new workspace because he's not in strict contact with the console, so he doesn't know. Students. Okay. And take a look at it. Okay. In this exam, if you want, you have the questionnaire also. I didn't give you the code book, but I gave you the questionnaire this time. Okay. It was a questionnaire submitted to students, and they answer more or less randomly, as you can see from some strange birth towns. Okay, let's start. We have to start also to open also Word, just to be sure I save it in the right place to avoid losing it, and with the right name. Okay, as I told you before, in this Word file, I expect you to copy and paste some output, not all of them, because if you copy all of them, you give me the impression that you are doing things mechanically without understanding anything. To write very short comments schematically, okay, to export all the graphs that you make, okay, to write the H0 hypothesis of the test, whether you accept, whether you reject, and what's the implication. Okay, let's start. Use tools to check. Oops. Whether there are evident data mistakes. Okay. No, sorry. Sorry, this one was wrong. So no. Analyze numerically and graphically your sample for town of birth, for year of birth, and for sex. So, let's start. I like starting with graphically, but you can start with whatever you want. Summaries. Let's start with. So, town of birth is frequency, obviously. Town of birth. Well, you can do it also together with year of birth. Now, year of birth not, and for sex. Sex, and town of birth. Okay. Don't click here. Okay, obviously town of birth has a lot of values, while sex, not so many. So I put sex here. I leave space because I will put a graph of sex later on. Let's change it to Miriam fixed, which is much better for the professor who will have to look at it. Okay, leave space. Now the town. Unfortunately, towns are really many. When your variable has many categories like town, it's pointless that you display also the percentages, because who cares that 0.5, it's always 0.5, can you see 6? Okay, so numbers are enough. Let's convert it to Miriam fixed, so it's much better to look at it. We have to convert to a very small, okay. It's almost invisible, but who cares? It will be the professor who will have to see it. Let's display the graphs of sex. Don't display the pie chart if you have two values, so it's much better to display, where is it? A bar graph of sex. Okay. Hop. A little comment, more or less the same frequency. Okay, so this is enough. You don't have to write a scientific article, so my word has stuck. Okay. Now here, a graphical representation. Or I choose pie chart for if it arrives for the town. Okay, it was not the best choice. But also choosing a bar plot, it was not so good. Okay, we can see clearly that majority from Bozen. Can I have the font a little better? Then Brix and Brunek, and I bet this one is Meran. In fact, Meran. And Meran, Brix and Brunek, Brix and Brunek. Okay. The rest is scattered around. It would have been be good to do a recording. Maybe I will ask in one of the next exams, a recording all the German towns, but you will spend 2 hours. Okay. A year of birth now. Year of birth completely different. I have to ask for numerical summaries. Birth. By the way, if it is not written, well, give at least the variable name, otherwise I will have to guess. Well, in this case, it's easy to guess because an average of 1984, average 1984, small standard deviation, meaning that distribution is compact. Okay. A graphical representation, we can do the histogram maybe. We can do the histogram of the box plot. Not necessary to do both. Both. Okay. You can see there is the usual nice guy who says to be born in 1900, which completely screws up all our histogram. We could split in more bins, but we have here a lot of empty things. In this case, you must build a box plot. This histogram, I will consider it partially correct if you build an horrible histogram like this one. Birth. Okay. Okay, the nice guy here and all the rest of distribution shrunk here. Copy as bitmap. So comment person 195 too low value, all the rest squeezed in the mid 80s. Okay. We thank person 195. Analyze only graphical year of birth and first year of elementary school in your sample. Set both variable to NA for the one subject with evident data mistake. So subject with evident data mistake is 195. Okay. Theoretically, how I wrote, you have to do first the graphical analysis and then set it. So let's do first the graphical analysis. We obey what the professor said. First the graphical analysis, birth and year L. The scatter plot is the graphical analysis. Op. Copy at bitmap. As usual, our friend forces the entire distribution to stay here, but you can see it's more or less linear. So practically fully linear. The only thing I can say is that these people have a smaller birth than year of elementary. No, have a larger birth than year of elementary. Okay, these people I believe are people who went to school later. Okay, these two people are people who went to school 1 or 2 years earlier. I doubt subject 98 went to school so early. Because you can see he went to school in 1980. He was born in 1985 and went to school in 1982. He was born approximately 1985 and went to school in 1982. Okay. Anyway, the professor asked us to change only one subject with evident data mistake. It's 195. So, edit. Okay. We search for subject 195. And now it's a problem. It's ID 195 or is the row name? Well, ID 195 doesn't exist, so it's the row name. Okay, here we have the nice guy. He says to be born in Buenos Aires, so this one to NA and this one to NA. Okay. Exit and save. Okay. Copy as bitmap. Okay, Judge already copied. Just to make the professor happy, let's redo it, even though it's not required. Can I redo it? Still here. Let's see. Sometimes R works terribly. Still here. NA I type it myself. Okay. Oh. There is apparently no way to remove it. So we'll do it manually. But manually it's not 100. So students dollar birth of 195 set to NA. Op. Yeah, L. Op. Let's do it now. So I've learned a new thing that editor doesn't. Okay, the editor doesn't work. It's good. Okay, we have to fix the exam. I suggest to do it manually. Okay. Build a new variable equal to year of birth plus 6. Analyze whether this variable is similar to the first year of elementary school. So first of all, let's build a new variable. It's pretty easy. You build it with compute new variable. Let's call it birth 6, which will be equal to birth plus 6. Okay, let's check because you never know. Yes. Okay, and now analyze whether it's similar to first year of elementary school. Pay attention, the two variables measure the same thing, a year. Okay, I added 6 because I expect you to go to school exactly 6 years after birth. Okay, let's see. So first of all, let's display the numerical summaries for the two variables. By the way, just to remind me of what you have done, I will put in the thing here, just to remind, it's not necessary because I'm still able to see it from here, but you never want the professor to forget about it. So, birth. Okay. Now let's also the creation of the variable. It's not strictly necessary, but when I will correct it, I will be able to see clearly what you've done. Okay. Not birth, sorry, year of elementary school. I pick up the wrong variable. I picked the wrong variable. Statistics, summaries, numerical summaries, not birth, but it's year L. This is the reason why before the exam I give you 5 minutes before the code book or the questionnaire, so you can take a look at the variable and understand what's going on. Okay, so let's comment it out. Mean is very similar. Okay, also the other statistics. Okay, you can see the median 91. Okay, let's do the test. Oh, the graphical representation, sorry. How can we do two? Well, the graphical representation is still the scatter plot. It will be a little ridiculous because they are so similar that you will see. With except some people, they are very similar. So same variable except some people. Okay, not only a linear relation, it's really the same. 9065, 9075, 9075. Okay, let's do the appropriate test. Which is the appropriate test in this case? The two variables measure the same thing. The appropriate test here is not a Pearson. Okay, it's the student test for paired variable and the Wilcox sign rank test. So statistics paired test for birth 6 and year L. Okay, don't put all the information just to make me happy. Okay, let's write that it's a student's paired test. Student paired test. H0 hypothesis is mandatory. Average difference is 0. Average difference or difference of the average is the same. Literally, mathematically, it's the same. P-value 0.0501. Significance is exactly 5%. Slightly more. What do we do here? Well, we should accept because is more than 5%, which means that all data are not able to deny that average difference is 0. However, we could also reject as it honestly is very close to 5%. Let's the non-parametric even to non-parametric measures something different. Okay. Please, I don't ask you to write in perfect English, but it must be fully comprehensible without doubt. Okay, so you can see it's 5% point something, and I should accept. Well, accepting is not so bad after all. If you look at here, it seems pretty evident that they are the same. The average is the same. Okay. What you have on the left, you have also on the right. Here, what you have on the left, you have more or less on the right. However, this 0, 1 could also reject. It's almost 5%. So let's do the non-parametric. Non-parametric measures something different, but still can give us a confirmation. So statistics, non-parametric test, pair sample Wilcoxon test, birth 6 and year L. Okay. Okay. I don't write silly things. Instead, I write a useful thing, which is the H3 hypothesis. A position of the difference is around 0. P-value 0.003. We reject. Meaning that the difference not position around 0. Okay, this gives us a confirmation that we should have rejected also before, honestly. They don't measure exactly the same thing, but usually it's very rare that one rejects and the other no. Okay, let's go on. Analyze whether there is a relation between sex and favorite subject. Okay, so here contingency table. Sex, favorite. Okay, chi-square. Do you need the row percentages or column percentage? Honestly, I will tell you, I never remember. So I pick one randomly, then I see if it makes sense. If it makes sense, I keep it. If it doesn't make sense, I choose the other one. It is one of the cases in which you can do the test at the same time as the descriptive statistics. It's here. If you need to do the test. Okay, let's see. First of all, let's see the percentages. Ah, yes, the column percentage makes sense. For example, in statistics, you have 45% male and 54 female. Computer science, more predominance of male. Okay, makes sense. Okay, so it was column percentages. The chi-square test is here. I take everything and I comment it in my file. Oppete. Okay, frequency table. Let's reduce it so the professor can see it better. Okay, so let's comment it before we took column percentages, so we can see the split by sex. Okay, so in particular we see that 70% of male prefer computer science. Oh, no, it's wrong. It's wrong because I can tell only that among the people who prefer computer science, 70% are male and 29 are female. But this can be determined also by the fact that female are less. So no, this is wrong, this column percentage. The other one was correct. Okay. Row percentages. Let's repaste it. So when you comment many times, you find out whether it was correct or not. Let's comment it now. Okay, now we see that 22% of male prefers computer science, while only 8% of female prefers it. Okay. Oh, this makes sense because in this case, it doesn't matter. Male can be 20 times more, but you're talking about 20%, 22% of male. So even to take more or less doesn't matter because the percentage of their total. Okay. Economics is similar. Marketing preferred by female. Law also. Others are similar. As you can see, I don't write in a good language, in a good written English, but at least it's fully comprehensible and the professor can understand that I understood. Okay, Pearson chi-square test, H0 hypothesis. Classification by sex is influences favorite It means that if you are male or female, this influences your favorite subject. Okay? It cannot be the vice versa, obviously. Your sex is not influenced by your favorite subject. Okay, p-value 0.06, we should accept. We accept. But there is a warning here. So chi-square test is meaningless until we remove category. Which category was the responsible? Statistics, for sure. Statistics. These two expected frequency less than 5 probably are these ones, the true values of statistics. Let's make probably. Okay. Save. Let's go on. Build a new variable containing approximate subject 8 when the questionnaire was submitted. Okay. You have variable submit, so pretty easy. Age, so submit minus birth. Very easy. Okay, let's see. Let's see whether it makes sense. Yes, it makes sense. Analyze whether there is a relation between sex and number of passed exams, paying attention to normal prerequisite. Okay, this time we have to pay attention to normal prerequisite. So, sex and number of passed exams, first of all with a graph, and using appropriate colors. So, the graph with appropriate colors is the box plot. Plot by groups, sex, exams, where is exams? Okay, the graph. I would like to color it. Comma, col, equal, C. I don't even do anything with the palette. I just write here pink 0. Let's see whether it works. No, it's vice versa. Or better, it's like the bathroom doors of the first floor. Oop. Now let's also the numerical summaries of exams summarized by sex. Oop. Let's put some comments. Average is similar. Concerning median, it's this. Oh, there's a chaos here. Okay, this means SD interquartile range is this one, 0% is this one, 25%. Okay, median is the same. Median 21 for both. Box plot, similar. Okay, let's do the statistics. Parametric and non-parametric. Independent samples to test. Sex, exams. Students. Okay. H0 average of exams on population for male is equal for female. Okay, we accept that averages could be same. Now, however, we have to check the normality. It's required here, paying attention to normality prerequisite. So, first of all, let's do the QQ-plot. It's the one I like best. I don't know you, but... but we have to do it by sex. So, first we subset. Where is the subset here? Subset expression, sex equal male. For male, all the variables, name for the new subset, male only. Error text. It was equal, sorry, not equal. Okay, now the QQ-plot. Exams. Normal. Evident non-normality. Let's see the other three techniques for male. Okay, where is the test? Shapiro-Wilk. H0, distribution of normal, rejected. Well, honestly, you could stop here, but we have said that we will do all four. Let's do. So even though it was required to do only two, we'll do all four just to show you how to do them. And now, the numerical summaries, exams. Op, 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 op. Horribly different from 0 and 3, meaning that distribution is skewed. And since I don't remember whether on the left or on the right, what do? I take the slides which are available. So positive tail to the right, skewed to the right, and too pointy. Okay, let's see the histogram. We are still working on male only, so we should do everything back again for female only, but we don't need, because male is already non-normal. It's evidently not normal. Okay, in any way, we try to draw the normal curve above. How to do it? Well, it's written here. Add prob equal true. So we have to close it. And I will add also col equal at 0, C. 0. Ah, there's already written. I also changed the color. Okay. Now I copy and paste from here. I have to get the A and S. Them. Okay, so I need okay. Now I can write A, it's 23.84 and S 11.82. Oh, wonderful. Because it's far different here. It's too pointy and too skewed. Here there is no left tail. Too pointy, evidently. Since male already failed, we do not do it for female. Now the non-parametric version, so the non-parametric test. Pay attention to go back to the full sample. Statistic, non-parametric, paired samples Wilkerson test, also called Mann-Whitney. Sex and exams. Ah, no, it's not a paired. Two samples Wilkerson test, sex and exams. Mann-Whitney. H0, position of distribution of exams is the same for male and more than the same, it's more or less in the same position. Okay, we reject. No, we accept, sorry. Two distributions could have the same position. Okay, finish. We close this one. Don't close R because you have to save the script. Exam. The output. I ask you to save everything because I'm pretty sure that you will have done some chaos and I will have to reconstruct what you were doing. The workspace. Exam. Okay. Now, before closing it, you check that everything is here. Everything is here. You close. Okay. And now you save everything back, excluding the database that you have already copied. Well, you have left the thing open. Students data you can replace, doesn't matter. In order to check now that you have copied everything, you look carefully at the date and the time. You don't reopen clicking randomly. Okay, and exam is over.